July 8, 1941, near Seno, Belarus. Oberst Wilhelm Ritter von Thoma stands in a field examining the burned wreckage of what appears to be a Soviet tank, unlike any his forces have encountered in the 2 weeks since Operation Barbarossa began. And even in its destroyed state, the tank's design features are striking enough to make him pause, despite the urgent demands of continuing the offensive. The turret is blown off and lying several meters from the hull. The armor plates are blackened and twisted from internal fires, but von Thoma can see that the frontal armor is sloped at a dramatic angle, rather than vertical like German and most other tanks. The tracks are extraordinarily wide compared to German tanks of similar weight class, and the main gun appears to be a 76mm weapon that's larger than anything the Germans expected Soviet forces to possess in significant numbers. Von Thoma has been a tank officer since the early 1930s and fought in the Spanish Civil War commanding German tank units, and he considers himself reasonably knowledgeable about armored vehicle design and the capabilities of potential enemy armor. But this Soviet tank represents something unexpected, because German intelligence assessments before Barbarossa had consistently downplayed Soviet tank development and suggested that Soviet armored forces were equipped primarily with obsolete light tanks and poorly designed medium tanks that would be inferior to German Panzer IIIs and IVs. The reality that von Thoma and other German commanders are discovering in these first weeks of the invasion is dramatically different from what intelligence predicted. And this burned-out tank with its unusual design features represents a problem that German forces will need to understand if they're to maintain the armored superiority that has been fundamental to blitzkrieg tactics. The tank is later identified as a T-34, a new Soviet medium tank that has only recently entered service and which is appearing in increasing numbers as German forces push deeper into Soviet territory, and initial combat reports about the T-34 are alarming enough that German Army Command decides that capturing an intact example for detailed technical examination must be a priority. German tank crews report that their standard 37mm anti-tank guns are ineffective against the T-34's frontal armor, that even the 50mm guns on later model Panzer IIIs struggle to penetrate at normal combat ranges, and that the T-34's 76mm gun is destroying German tanks with ease from distances where German tanks cannot effectively fight back. These reports are initially met with skepticism at higher command levels because the idea that the supposedly backward Soviets could produce a tank superior to German designs contradicts every assumption about Soviet industrial and technical capabilities. But as more encounters occur and more German tanks are destroyed by T-34s, the reality becomes impossible to deny. By August 1941, German forces have captured several T-34s in various states of damage, and in early September, an intact T-34 is captured near Leningrad when its crew abandons the tank after it becomes stuck in marshy ground, and they cannot extract it before German forces overrun the position. The captured tank is transported to Germany for comprehensive examination at the Kummersdorf, proving grounds where German tank designers, metallurgists, and military experts can conduct the systematic testing and analysis needed to understand exactly what makes the T-34 effective and how German tanks might be improved to counter it. What these German experts are about to discover will fundamentally challenge their assumptions about tank design, will reveal that Soviet engineers have solved critical problems in ways that German designers haven't considered, and will ultimately lead to the development of the Panther tank and significant modifications to German armor doctrine. The examination team assembled at Kummersdorf represents Germany's leading tank development expertise and includes engineers from Daimler-Benz, MAN, Henschel, and other firms involved in armored vehicle production, along with military officers who have combat experience against Soviet armor, and metallurgists who can analyze the steel composition and manufacturing techniques used in the T-34's construction. These experts approach the examination expecting to find a tank that is crude in construction, primitive in design, and inferior in most technical aspects to German tanks, because this expectation aligns with German assumptions about Soviet industrial capabilities and the general belief that German engineering represents the pinnacle of technical achievement. What they actually find when they systematically examine the intact T-34 will shock them and force a fundamental reassessment of Soviet capabilities. The first comprehensive inspection of the T-34's exterior immediately reveals design features that German engineers find both innovative and troubling, and the most striking feature is the armor sloping that gives the tank its distinctive profile. The frontal hull armor is 45 mm thick, but sloped at approximately 60 degrees from vertical, and German engineers quickly calculate that this sloping provides significantly more effective protection than the raw thickness suggests, because projectiles hitting sloped armor must penetrate a greater thickness of steel than armor of the same thickness placed vertically. A shell striking the T-34's 45 mm frontal armor at a perpendicular angle to the slope must actually penetrate approximately 90 meters of steel due to the angle, and this means that the T-34's frontal protection is roughly equivalent to a German tank with 90 meters of vertical armor, despite using only half as much steel. This revelation is profound because German tank designers have generally used vertical or near-vertical armor on their tanks, calculating that increased thickness was the way to improve protection, but the T-34's sloped armor demonstrates that geometric arrangement can provide equivalent or better protection while using less steel, reducing weight, and simplifying manufacturing. German engineers examine the welded joints where the sloped armor plates meet and find that Soviet welders have developed techniques for joining plates at acute angles that German manufacturers haven't mastered, and the quality of the welds is surprisingly good considering German assumptions about Soviet industrial capabilities. The sloped armor design also provides a secondary benefit that German engineers recognize immediately. Shells that don't penetrate the armor are more likely to deflect off the sloped surface rather than transferring their full kinetic energy into the armor, meaning that even non-penetrating hits are less likely to cause spalling or internal damage. The second striking feature is the T-34's tracks, which are extraordinarily wide at 500 mm compared to the 380 mm tracks on the Panzer IV, or the even narrower tracks on earlier German tanks, and this width has immediate implications for ground pressure and cross-country mobility. German engineers calculate that the T-34's ground pressure, the weight of the tank distributed across the area of the tracks in contact with the ground, is significantly lower than German tanks of comparable weight, and this lower ground pressure means the T-34 can traverse soft ground, mud, and snow that would bog down German tanks. Soviet engineers have essentially designed the T-34 for the specific terrain conditions of the Eastern Front, where roads are poor, mud is ubiquitous in spring and autumn, and winter snow can immobilize vehicles with inadequate ground clearance and narrow tracks. And these wide tracks give the T-34 a mobility advantage that German tanks cannot match in these conditions. When German engineers open the engine compartment to examine the power plant, they find a V12 diesel engine producing approximately 500 horsepower. And this discovery generates considerable discussion because German tanks universally use gasoline engines, and German tank designers have generally dismissed diesel as inferior for armored vehicle applications. The T-34's diesel engine is designated the V2 and is derived from aircraft diesel engine development, and German engineers quickly recognize several advantages that diesel provides. The fuel is less volatile than gasoline and therefore less likely to ignite catastrophically when the tank is hit. Diesel fuel has higher energy density, allowing longer operational range with the same fuel capacity, and diesel engines generally run cooler than gasoline engines of similar power output, which reduces the size and complexity of cooling systems. The V2 engine is relatively crude in construction with loose tolerances and simple fuel injection, but these characteristics make it robust and easy to maintain under field conditions where precision tools and clean working environments aren't available. The examination of the T-34's transmission and drivetrain reveals a different design philosophy than German engineers are accustomed to, with Soviet designers clearly prioritizing simplicity and ease of manufacture over refinement and driver comfort. The transmission is a relatively crude 4-speed gearbox that requires substantial physical effort from the driver to shift gears, and there's no synchromesh or other assistance to make gear changes smooth. The driver must carefully match engine speed to the next gear's requirements, or risk grinding gears and causing damage. German engineers note that this transmission design would be considered unacceptably primitive by German standards, where more sophisticated transmissions with easier gear changes are standard, but they also recognize that the T-34's simple transmission is far less likely to fail under combat conditions, requires minimal specialized maintenance, and can be repaired in field workshops using basic tools. When German metallurgists analyze samples of the T-34's armor steel, they find that the metallurgical quality is generally good with appropriate hardness and toughness characteristics for armor applications, though the quality varies more than would be acceptable in German production, with some plates showing better properties than others. This variation suggests that Soviet steel production is less consistent than German production, but the average quality is adequate for the purpose, and Soviet manufacturers are compensating for inconsistency through testing and selection rather than achieving uniform quality in all production. The armor plates show evidence of relatively crude manufacturing techniques with surface irregularities and weld spatter that would not pass German quality control standards. But none of these cosmetic flaws actually compromise the armor's protective capability, and German engineers begin to realize that Soviet manufacturers are focusing on functional effectiveness rather than aesthetic perfection. The examination of the T-34's 76mm gun reveals another area where Soviet designers have made different choices than their German counterparts, and the gun is designated the F-34 tank gun, which is a development of Soviet divisional artillery adapted for tank mounting. The gun has excellent penetration capability with armor-piercing ammunition capable of defeating 60 millimeters of armor at 1,000 meters, which means it can penetrate the frontal armor of any German tank in service in 1941 at normal combat ranges. German engineers note that the gun's construction is relatively simple compared to German tank guns of similar caliber, with less sophisticated manufacturing and finishing. But the ballistic performance is impressive, and the simple construction makes the gun easier to produce in quantity. The gun mounting and recoil system are robust if crude, and the entire assembly demonstrates Soviet prioritization of battlefield effectiveness over manufacturing sophistication. When German test drivers operate the captured T-34 on the proving grounds. They report that the tank is difficult to drive by German standards with heavy controls, difficult gear changes, poor visibility from the driver's position, and harsh ride characteristics over rough terrain. But they also note that the tank's performance in soft ground and snow is remarkable, with the wide tracks allowing the T-34 to traverse terrain that would stop German tanks. The test drivers find that the T-34 accelerates adequately and reaches a maximum speed of approximately 55 kilometers per hour on roads, which is comparable to or better than German medium tanks, and the operational range of approximately 300 kilometers with internal fuel plus external tanks is significantly better than German tanks, which typically achieve 150-200 kilometers depending on terrain. The testing of the T-34's armor protection confirms what German tank crews have been reporting from combat encounters. German 37mm anti-tank guns cannot penetrate the T-34's frontal armor at any range. The 50mm guns on Panzer IIIs can only penetrate the frontal armor at very close range under ideal conditions, and even the 75mm gun on the Panzer IV, which is primarily designed for firing high explosive shells at infantry and fortifications rather than armor-piercing ammunition at tanks, struggles to reliably penetrate T-34 armor. German engineers conduct live fire tests using various anti-tank weapons against the captured T-34's armor and confirm that the sloped armor is providing protection equivalent to much thicker vertical armor, and shells that don't penetrate are frequently deflected by the slope rather than transferring their energy into the armor. As German engineers compile their findings from examining and testing the captured T-34, a consensus emerges that is disturbing to German military leadership and fundamentally challenges pre-war assumptions about Soviet capabilities. The T-34 is not a crude, primitive tank produced by backward Soviet industry, but rather a well-designed medium tank that represents a sophisticated solution to the specific requirements of armored warfare on the Eastern Front and in several critical areas: armor protection through sloping, mobility in difficult terrain through wide tracks, and operational sustainability through diesel power. The T-34 is superior to German tanks. The realization that Soviet engineers have designed a tank that is in many ways better than German tanks contradicts the racial ideology that underpins Nazi beliefs about Slavic inferiority, and German experts struggle to reconcile the evidence of their examination with the assumptions they brought to the analysis. The German response to the T-34 revelation involves both immediate tactical measures and longer-term strategic decisions about tank development, and the tactical response includes deploying the 80DE mid-arm anti-aircraft gun in an anti-tank role, because this powerful weapon can reliably penetrate T-34 armor at combat ranges, modifying existing German tanks to carry more effective anti-tank weapons, and developing new armor-piercing ammunition with better penetration characteristics. The strategic response involves initiating development programs for new German tanks that can match or exceed T-34 capabilities, and these programs will ultimately produce the Panther medium tank and modifications to the Tiger heavy tank program that incorporate lessons learned from examining the T-34. The development of the Panther tank represents the most direct German response to the T-34 challenge, and when German firms are asked to submit designs for a new medium tank in autumn 1941, the specifications explicitly call for sloped armor inspired by the T-34, wide tracks for improved mobility, and sufficient armor and armament to engage T-34s on favorable terms. Daimler-Benz submits a design that is essentially a copy of the T-34 with German components, while MAN submits a design that incorporates the sloped armor principle while maintaining distinctly German design characteristics, and the MAN design is ultimately selected for production as the Panther, despite Daimler-Benz's design being closer to the T-34 that inspired the program. The Panther that enters production in 1943 clearly shows T-34 influence in its sloped frontal armor, 80 mm at 55 degrees, providing protection equivalent to approximately 140 mm of vertical armor, and in its relatively wide tracks and emphasis on mobility. But German designers cannot resist adding complexity and sophistication that the T-34 deliberately avoids. The Panther uses a sophisticated Maybach engine and transmission similar to the Tiger systems rather than adopting the T-34's simple, robust approach, mounts a powerful 75mm gun that's technically superior to the T-34's 76mm gun, but requires precision manufacturing, and incorporates numerous technical refinements that improve performance under ideal conditions but compromise reliability and ease of maintenance under field conditions. German engineers essentially learned the wrong lesson from examining the T-34 by copying the innovative features like sloped armor, while failing to understand that the T-34's superiority comes not just from specific design features, but from an overall philosophy of simplicity, robustness, and manufacturability. The examination of the captured T-34 also reveals to German experts the extent to which Soviet tank design philosophy differs fundamentally from German approaches, and these philosophical differences reflect broader contrasts in how the two nations approach military equipment design and industrial production. Soviet designers have clearly prioritized several characteristics over others: battlefield effectiveness over crew comfort, simplicity over sophistication, ease of manufacture over precision engineering, and robustness under harsh conditions over maximum performance under ideal conditions. The T-34's crude transmission that requires physical effort to shift gears is inferior to German transmissions in terms of driver comfort and ease of operation, but it's far superior in terms of reliability, ease of repair, and suitability for production by workers with minimal specialized training. German tank design philosophy, by contrast, prioritizes technical excellence, precision engineering, crew comfort, and maximum performance, and these priorities lead to tanks that perform better in many measurable ways but which are difficult to manufacture, require skilled crews and maintainers, and are vulnerable to reliability problems under harsh conditions. The examination of the T-34 forces German engineers to confront the reality that pursuing technical excellence has created tanks that are over-engineered for the actual conditions of warfare on the Eastern Front, and that Soviet designers' acceptance of crude features and rough finish has produced a tank that is more effective in combat despite being inferior in many individual technical characteristics. The production comparison between T-34 and German tanks reveals perhaps the most important lesson that German examination of the captured T-34 provides, though it's a lesson that German leadership proves unable to fully internalize and act upon. Soviet factories are producing T-34s at rates that dwarf German tank production, and the reasons for this production advantage become clear when German engineers understand the T-34's design philosophy. The T-34 uses simple components that can be manufactured with relatively crude machine tools by workers with minimal training. The design tolerates variation in component quality that would be unacceptable in German production. Assembly processes are simplified to minimize skilled labor requirements, and the entire design reflects an understanding that producing adequate tanks in overwhelming numbers is more valuable than producing excellent tanks in limited quantities. German tank production, by contrast, requires precision machining, skilled workers, tight tolerances, and time-consuming assembly processes, and these requirements limit production rates even when factories are operating at maximum capacity. The Panther, despite incorporating sloped armor inspired by the T-34, requires approximately 10 times as many man-hours to manufacture as a T-34, because German engineers cannot resist adding complexity and precision that requires specialized manufacturing. The result is that Soviet factories produce approximately 10 T-34s for every Panther that German factories complete, and this production ratio means that even if the Panther is technically superior to the T-34 in direct combat, German forces are outnumbered by such enormous margins that technical superiority cannot overcome numerical inferiority. The metallurgical examination of T-34 armor samples reveals another aspect of Soviet industrial philosophy that German experts find both troubling and impressive, which is that Soviet steel production tolerates higher variation in quality than German production, but achieves adequate results through testing and sorting rather than through uniform quality control. Some T-34 armor plates show excellent metallurgical properties, while others are somewhat inferior. And German metallurgists initially interpret this variation as indicating poor Soviet quality control. But deeper analysis reveals that Soviet manufacturers are testing plates and selecting the best examples for critical applications like frontal armor, while using lower quality plates in less critical areas. This approach allows Soviet factories to maintain high production rates without rejecting plates that don't meet strict specifications, and the functional result is adequate armor protection produced in massive quantities rather than perfect armor produced in limited quantities. German metallurgists note that Soviet welding techniques, while crude by German standards with visible weld beads and spatter, are functionally effective and produce joints that are strong enough for the purpose, and that Soviet welders are clearly trained to produce adequate welds quickly rather than perfect welds slowly. This observation reinforces the broader pattern that emerges from the T-34 examination. Soviet industrial practice prioritizes speed of production and functional adequacy over aesthetic perfection and technical sophistication, and this priority system allows Soviet industry to outproduce German industry by enormous margins while achieving equipment that is good enough to win battles. The examination of the T-34's diesel engine leads German engineers into extended discussions about the trade-offs between gasoline and diesel power plants for armored vehicles. And while German tank designers ultimately continue using gasoline engines in most applications, the T-34 examination forces them to acknowledge that diesel offers significant advantages that they had previously dismissed. The lower fire risk from diesel fuel is particularly important, given combat experience showing that gasoline-fueled tanks often burn catastrophically when hit, and the T-34's diesel engine provides a measurable survival advantage for crews because even when the tank is penetrated by enemy fire, the diesel fuel is less likely to ignite than gasoline. The longer operational range that diesel provides is also significant for the vast distances of the Eastern Front, where German tanks frequently run out of fuel before completing missions, and the T-34's ability to operate 400 kilometers on internal fuel gives Soviet forces operational flexibility that German tanks cannot match. German test drivers who operate the captured T-34 extensively report that while the tank is uncomfortable and difficult to operate by German standards, it's remarkably forgiving of operator error and continues functioning under conditions that would disable German tanks. The simple transmission, while requiring heavy physical effort to shift, is nearly indestructible and can tolerate significant abuse from inexperienced drivers without failing. And this robustness is valuable for an army that must rapidly train large numbers of tank drivers to replace combat losses. The wide tracks that give the T-34 its superior mobility in mud and snow also provide a larger margin for driver error in difficult terrain because the tank is less likely to bog down or lose traction, and German test drivers note that the T-34 would be easier for a novice driver to operate in combat conditions than German tanks that require more skill to handle effectively. The optical systems and vision devices on the T-34 are examined and found to be significantly inferior to German equivalents, with the periscopes providing limited visibility, the gun sights being crude and offering less magnification than German sights, and the overall arrangement giving the crew worse situational awareness than German tanks provide. German experts initially seize on these deficiencies as evidence of Soviet technical inferiority, but they gradually realize that Soviet designers have deliberately accepted poor vision devices as a trade-off for other priorities, and that in the close-range engagements that characterize much Eastern Front armor combat, the T-34's vision limitations are less critical than they would be in longer-range engagements where German optical superiority would provide greater advantage. The crew ergonomics inside the T-34 are universally judged by German examiners to be poor, with cramped quarters, uncomfortable seating, limited stowage for crew equipment, and working conditions that would be considered unacceptable in German tanks, where crew comfort is a design priority. The German testing reports note that prolonged operation of a T-34 would be fatiguing for the crew and would degrade combat effectiveness over extended engagements, but they also note that the compact internal layout contributes to the T-34's relatively small size and lower weight, which provide tactical advantages in concealment and mobility. Soviet designers have apparently decided that crew fatigue over long operations is an acceptable trade-off for a smaller, more mobile tank, and this calculation reflects an assumption that tank combat will typically consist of relatively brief, intense engagements rather than prolonged battles where crew endurance becomes critical. The ammunition stowage arrangements in the T-34 are examined and found to be adequate but not optimal, with shells stored in various locations throughout the fighting compartment where they're vulnerable to enemy fire that penetrates the armor. And German experts note that German tanks typically provide better ammunition protection through armored bins or positioning shells away from likely penetration points. The T-34's ammunition stowage reflects Soviet acceptance of vulnerability in exchange for maximizing the ammunition load and simplifying the internal layout. And combat experience would later show that T-34s do indeed frequently experience catastrophic ammunition explosions when penetrated. But Soviet forces accept these losses as part of the overall calculation that producing more tanks matters more than making each tank marginally more survivable. The maintenance accessibility of the T-34's major components is evaluated and found to be mixed, with some systems like the engine being relatively easy to access for field maintenance, while other components require significant disassembly to reach. And German examiners note that Soviet designers have clearly prioritized making the most common maintenance tasks simple, while accepting that less frequent repairs might require more effort. The diesel engine can be removed and replaced in field conditions using basic lifting equipment and tools. The tracks can be repaired or replaced without specialized equipment, and the transmission, while crude, can be serviced by mechanics with minimal training. German tanks typically require more specialized tools and more skilled mechanics to maintain. And this difference reflects Soviet emphasis on keeping equipment operational under primitive field conditions where sophisticated workshops and highly trained technicians aren't available. The overall conclusions that German experts reach after completing their comprehensive examination of the captured T-34 represent a fundamental challenge to pre-war German assumptions about Soviet capabilities and force a reassessment of German tank development priorities, though the reassessment proves incomplete and German designers continue making many of the same mistakes that the T-34 examination should have corrected. The German experts recognize that the T-34 is a well-designed tank that represents sophisticated engineering applied to clearly understood requirements, that Soviet designers have solved critical problems in innovative ways that German designers should learn from, and that the T-34's combination of adequate performance in all areas with excellent manufacturability gives Soviet forces a strategic advantage that German technical superiority and individual characteristics cannot overcome. But the lessons that German tank development actually learns from the T-34 examination are selective and incomplete, with German designers adopting specific features like sloped armor while failing to embrace the underlying philosophy of simplicity and manufacturability that makes those features effective. The Panther incorporates T-34-inspired sloped armor, but couples it with a sophisticated transmission that frequently fails, a complex engine that requires skilled maintenance, and precision-manufactured components that limit production rates, and this hybrid approach produces a tank that's technically impressive but strategically ineffective, because Germany cannot build Panthers in sufficient numbers to offset Soviet numerical superiority. The fundamental lesson that producing adequate tanks in overwhelming numbers defeats producing excellent tanks in limited quantities is intellectually understood by German experts who examine the T-34, but is never fully implemented in German tank production because German industrial culture, engineering traditions, and organizational inertia all resist the radical simplification that Soviet practice represents. The T-34 examination also reveals to German experts the extent to which Soviet tank design is specifically optimized for Eastern Front conditions rather than being a general-purpose design intended for varied terrain and climates. And this specificity gives the T-34 advantages that are particularly valuable in the theater where it's actually fighting. The wide tracks that provide excellent flotation in mud and snow would be less advantageous in North African desert conditions or Western European road networks. The diesel engine that provides cold weather starting advantages and reduced fire risk is optimized for Soviet climate and tactical conditions, and the overall design reflects Soviet understanding that their tanks will fight primarily on Soviet territory under Soviet weather conditions against German tanks, rather than needing to perform well in varied global conditions. German tanks, by contrast, are designed as general-purpose vehicles intended to perform adequately in North Africa, Western Europe, and Eastern Front conditions, and this design-for-everywhere approach results in tanks that are optimized for nowhere. The captured T-34 that German forces examined at Kummersdorf in late 1941 becomes one of the most consequential pieces of captured equipment of World War II, because the insights gained from its examination influenced German tank development throughout the remainder of the war and provide clear evidence that Soviet industrial and engineering capabilities far exceed German pre-war estimates. The T-34's combination of sloped armor, wide tracks, diesel power, and simple, robust construction represents a coherent design philosophy that prioritizes battlefield effectiveness and mass production over technical sophistication and crew comfort. And this philosophy proves more effective for winning a war of industrial attrition than German pursuit of technical excellence that produces superior individual tanks in inadequate quantities. The T-34 continues to serve as the primary Soviet medium tank throughout World War II, with incremental improvements, including the upgunned T-34-85 variant that mounts an 85mm gun capable of defeating German heavy tank armor, and over 84,000 T-34s are produced during the war, making it the second most produced tank in history after its successor. This massive production run reflects exactly the philosophy that German examination of the captured T-34 reveals, that a good enough tank produced in overwhelming numbers defeats a technically superior tank produced in limited quantities, and that simplicity and manufacturability are strategic, assets as valuable as thick armor or powerful guns. German tank production never approaches Soviet output levels, despite Germany's sophisticated industrial base and skilled workforce, because German designers cannot or will not embrace the radical simplification and acceptance of crude features that characterize Soviet practice, and German tanks remain over-engineered, difficult to manufacture, and produced in quantities that prove strategically insufficient. The approximately 6,000 Panthers and 150 Tigers that Germany produces during the war represent technical achievements that showcase German engineering capabilities. But these impressive tanks cannot overcome the 84,000 T-34s plus tens of thousands of other Soviet tanks that outnumber German forces by ratios that make tactical superiority irrelevant. The story of German scientists examining a captured T-34 and realizing they had underestimated Soviet Russia is ultimately a story about how preconceived assumptions can blind even experts to reality, how technical sophistication can become a liability when it compromises manufacturability, and how design philosophy, reflecting clear understanding of strategic requirements, defeats pursuit of excellence that loses sight of what actually matters for winning wars. The T-34 was not the most sophisticated tank of World War II, not the most powerful, not the most comfortable for crews, and not the most precisely manufactured, but it was exactly the right tank for the war that the Soviet Union needed to win. And German examination of the captured T-34 revealed this reality, even though German industry proved unable to fully apply the lessons that examination provided.